Alright, without graphing, let's take a look at predicting the number of solutions a given system may have. We have three different scenarios in this case. We could have no solution, we could have a single solution, or we could have an infinite number of solutions. Let's take a look at how we would arrive at each of these scenarios. For no solution, that means that you would have to have parallel lines. So, parallel lines. So if we looked at the parallel lines, you could see that they do not have any points in common. And the solution to a system is that point of intersection. So no solution means no points in common. So we know that parallel lines have the same slope but different y-intercepts. Alright, a single solution. A single solution simply means that you have intersecting lines. So you have a line here, another line here, and the point of intersection is the solution to that system. Remember, intersecting lines simply don't have the same slope. Also, if you have intersecting lines, you would be able to find the xy pair that represents that point of intersection. Infinite solutions just mean that you have the exact same line. Maybe it's written in a couple different formats. Maybe one is, 3 times larger than the other, so the numbers weren't recognizable. Whatever the case is, infinite solutions means that you have the same line described two different ways. So if you had this line as one of the equations and the exact same line as the other equation, you could see how you would have infinite solutions because they have every single possible point in common. So the same line obviously would have the same slope and the same y-intercept. So let's take a look at one of each of these possible scenarios in an example. All right. So let's take a look at this system of equations. We have 3x plus 6y equals 18 and x plus 2y equals 6. I think the easiest approach at this point is to simply put both equations in y equals mx plus b, because you can identify the slope and the y-intercept so easily in that format. So I'm going to actually take this system and break it up so that I can work the two problems side by side. So I have the 3x plus 6y equals 18 over here on the left, and the x plus 2y equals 6 over here on the right. And I'm just going to kind of make a little t-chart so I can work them side by side and see what's going to happen. So starting with the 3x plus 6y equals 18, I'll subtract 3x from both sides. That'll leave me 6y equals a negative 3x plus 18. Then I'll divide every term by 6. So we have y equals a negative 3/6 reduces down to a negative 1/2 x, and a positive 18/6 reduces down to 3. So let's just look. Here's our slope and our y-intercept. And we're going to look and see if the other equation has the same slope and or y-intercept and see how many solutions this system would have. So over here we'll start by subtracting x from both sides, giving us 2y equals negative x plus 6. Divide every term by the coefficient. So y equals a negative 1/2 x plus 3. So here is the slope, and here is the y-intercept. So if we look at these, they have the exact same slope and the same y-intercept. So we have infinite solutions because we're dealing with the same line. So this has, I'm out of space here, but infinite solutions. Alright, moving on, let's look at an example of a single solution or no solution. Let's say we have a system with the equations 5x plus 2y equals negative 4 and x minus 2y equals negative 8. Again, I'm just going to put these in y equals mx plus b so I can see what I'm dealing with. So let's go ahead and write them side by side. It's just a little bit easier for me to work them through when I have some space. So I'll start with 5x plus 2y equals negative 4. I'll subtract 5x from both sides, leaving us 2y equals a negative 5x minus 4. Then we'll divide every term by the coefficient so that we can get y by itself. We have y equals a negative 5/2 x minus 2. So let's look at the important information. Our slope in this case is a negative 5/2. Our y-intercept is a negative 2. Let's look at the other equation in the system. X minus 2y equals negative 8. So I'll start by subtracting x from both sides, leaving us negative 2y equals negative x minus 8. Divide every term by the coefficient, which is negative 2. And we have y equals negative divided by a negative is a positive 1/2 x. Negative divided by a negative is a positive. 8 divided by 2 is 4, so plus 4. So here we have a slope of 1/2 and a y-intercept of positive 4. So notice the slopes are different, the y-intercepts are different. We simply have intersecting lines. So since we have intersecting lines, it means that there is a point in common, and so we have one possible solution. All right, one more example. Let's look at this final system here, where we have 2x plus 3y equals negative 12, and 2x plus 3y equals negative 9. Now, this particular one, we don't even have to put in y equals mx plus b to see that they're very similar but not exact. Let's go ahead and put it in y equals mx plus b and see what conclusion we can draw. So again, I'm just going to write the equations out so they're easier to work with. Alright, so I'll start by subtracting 2x from both sides. Gives us 3y equals a negative 2x minus 12. Divide every term by the coefficient. So we have y equals a negative 2/3 x minus 4. Our slope and our y-intercept easily identifiable. Over here, we'll start by subtracting 2x from both sides. This leaves us 3y equals a negative 2x minus 9 this time. Divide every term by the coefficient, which leaves us y equals a negative 2/3 x minus 3. Again, we have our slope and our y-intercept. Really easy to locate and identify. So when we compare the information that we have a slope of negative 2/3 for both equations. So we know we're either dealing with the same line or parallel lines. The decision is going to come down to whether or not the y-intercept is the same. If the y-intercept and slope are the same, we're dealing with the same line. If the y-intercept is different and the slopes are the same, we have parallel lines. So we have two different y-intercepts, so these are parallel lines. So there are no solutions to this system of equations.